Hey folks, this is a short video to introduce you to finite differences with sequences of numbers. So finite differences we've actually talked about a little bit. We're simply talking about the difference between the term from term to term. So 3 to 7 would give you a difference of 4, and here would also be 4. And we found out early on that when this was constant, then this would be linear, and we could write this out as the nth term being 4n, and then all we had to do is figure out what that first term was going to be, and in this case minus 1 would give us the nth term of that arithmetic sequence, very quickly done using finite differences. Well, today we're going to explore this at a greater level. In this case, we're going to look at a quadratic sequence. So the first thing I'm going to do is I'm going to write out a few of these terms. So P1, P2, P3, P4. And let's see what those are. So if we just plug in a 1 for n, we end up with 4 minus 6 plus 5, which would be 3. So I'll just write a 3 there and box it. Okay, if we do P sub 2, then this would be 4 times 4, or 16, minus 12 plus 5. And of course, there you end up with 9. And then let's go to the third one. If we go to 3 here, we've got a 9 times 4, or 36, minus 18 plus 5, which turns out to be 23. I hope I did these right. It would be very helpful if I did. 16 times 4, 64, minus 24 plus 5. And in this case, this is going to be 45. Okay, now we have our first 4 terms in this sequence of numbers calculated out as P1 through P4. Obviously, we could continue down here if we wanted to. But let's find these finite differences. In this case, there's 6 as a difference. Here, it looks like there's a 14, and the last one looks like a 22. And then if we do the finite differences one more time, we notice that this is an 8 and this is an 8. And we see that that's the idea here, that instead of coming to the first one, and let's just go back one slide, we recall that in this case, in the first level, we ended up with a constant finite difference. But in our second situation, in the first one, we still have something here that is not constant, but it is instead linear. You could see that that is add 8, add 8. So this is actually linear, and this one is constant. So we have to go 2 different levels. Well, once we identify that something has come to a constant, we know that that is going to be some sort of polynomial. In other words, it might take 3 or 4 layers, but we should be able to figure out that that is a polynomial sequence. So let's do this one more time. And this time we're going to generate a nice little formula for ourselves. So we're not giving the a, b, and c coefficients, but in this case we're just going to write this out. If you let n equal 1, you'd have a plus b plus c. If you let n equal 2, we would have 4a, because that's going to be 2 squared, plus 2b plus c. If you let p equal 3, you'd get 9a plus 3b plus c. And I'll just do one more here. If I let p equal 4, I'd get 16a plus 4b plus c. All right. Now, in order to find the finite differences, we actually have to subtract P2 minus P1. So in that case, the 4a minus the a is 3a, the 2b minus the b is b, and then the c's drop out. In the second case here, we end up with, as you can see, 5a plus b, and in the third case, 16 minus 9 is 7a plus b again. Notice that as we go to the next level, we end up with just a 2a. Well, that's very helpful, because if we go backwards now, these A's, B's, and C's that we see in this first line, and let me just illustrate that this first line is kind of the important line, because we have now 3 different terms that we can back substitute for, and we have a system of A, B, and C, and notice that it only took us, and I'll just put a little dotted line right through here, it only took us these 3 terms to determine what the 2a, the 3a plus b, and then the a plus b is going to be. So we do need 3 terms, and we also need these 3 items, the 2a, the 3a plus b, and the a plus b plus c. So very simple to, you could even memorize these. Of course, we need to work this out with an actual example. So let's give that a shot. So now I have a quadratic sequence. Now I am convinced that it's a quadratic sequence only when I do the finite differences. So let me write this out sideways. It helps me a little bit better to write it this way. 1, 3, 7, 13, and 21. And let's do some finite differences here. This is going to be a 2. This is a 4. This is a 6. This is an 8. And this is going to be a 2. And this is a 2. And this is a 2. So once we've identified that this is indeed constant in the second layer, we know that this is quadratic. Now we want to look up that first line right there. We know that this is number 1, which is a plus, excuse me, I'm going to rewrite this again. This is number 1, 2, and 3, but let's go this way. Okay, let's conform to what we had in the last slide. So notice here, our number 1 is the last term. So this will be our number 1, this will be our number 2, and this will be our number 3. So we'll say number 1, 2a is equal to this number 2. Number 2, 3a plus b is equal to 2 as well. And number 3, a plus b plus c is equal to 1. Now with some simple back substitution, we can see that a is equal to 1, that from my first one, and then substituting that into the second equation, we have for number 2, 3 plus b equals 2, or b equals negative 1. And the last term, in number 3, we see that a plus b plus c is equal to 1. So 1 plus negative 1 plus c equals 1. Oh, that was silly. There's some really silly notation there. 1 plus negative 1. 1 minus 1, that's better. And so c equals 1 as well. All right, so this is a very simple problem. Let's take a look at what the answer is then. A sub n would be, since a is 1, we just have n squared. And since b is negative 1, we have minus n. And then c is equal to 1, so we should end up with plus 1. And that is our nth term. So very easily we can see that we just have to verify, first of all, this is why we have a little happy face down here. We're verifying that it is quadratic. Once we verify that it's quadratic, we use this first row of numbers to calculate our little system of equations, and from there we can solve for A, B, and C. Hope this helps you get started on your finite differences with quadratics.